Hello guys, welcome to today's video. A special shout out to Aryaman, Ninad, Shaurya, Arav, Akshit, Harshit, Patti and Venki. It would have been possible with the support of you guys. Thanks a lot. So today we would be discussing a problem on current electricity. So now this problem can be solved by the basic knowledge of class 10th, and it would require some concept of GP as well. It would require a concept called infinite GP. So I would be discussing what GP is for the first 2 to 3 minutes of this video, and then we'll be continuing with the problem. So I'll just this part of the problem would require GP, infinite GP plus concepts of class 10th, and this problem is solely based on the concepts of class 10th. So if you guys are familiar with GP, I'd advise you to try out both of these problems, and if you're not, try out this problem and then I'll explain what GP is. Feel free to pause the video. Okay, so I guess you guys would have tried by now, so let's begin. So let's discuss what GP is before beginning. So what is GP? GP is geometric progression. I assume you guys have heard about AP. AP is arithmetic progression. So if I take an example of AP, it would be 1, 3, 5, 7, dot, 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 dot. So there's a common difference of 2 between each of these terms. So basically, if I add 2 to one term, like if I add 2 to this, I'll get the next term of my AP. So now geometric progression, let us just start by an example. It would be 1, 2, 4, 8, dot, dot, dot. So in this, there's a product difference. Like if I multiply 2 by this, if I multiply 2 by this, I get this. So like it's basically you multiply a constant term in order to get the next term. If I say take another sequence 3, 9, 27. So now I'll ask you guys, find out the fourth term. This is a very easy problem. So find out the fourth term. So what will the fourth term be? See, the common difference between this is 3. The common difference between this is 3. So the common difference between this must be 3. This will be 27 into 3, which is 81. Right. Okay. I'll just give you one more problem before we go on to AP. So now, tell me the next term for this. What will be this term? I hope you guys have got your answer by now. So the answer is 64. There's a common difference of 2, there's a common difference of 2, there's a common difference of 2, so there must be a common difference of 2, so 32 into 2, 64. Easy, right? Yeah, it's pretty easy. So if I just write a generalized relation, may I write AP as A, AR square, dot, 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 AR n minus 1. This is the nth term, Tn. Right, see. So like there's a common multiple, then there's the square of the common multiple, goes on. So Tn is equals to AR n minus 1. We get this formula. Like it's basic. Right. So that's it. Now I'm just gonna write some formulas real quick. You'll have to learn them as of now. So sum of nth terms is equals to A into Rn minus 1, R minus 1. What is R? R is the common product difference. Like if I say common difference, it won't be accurate. I just mean what the number you have to multiply in order to get the next term. The common product difference, if I must say. The common product difference, Rn. And now this is like basic common sense. R should not be equal to 1. And now see, there are like two formulas floating around the internet. So people say that this is for R is greater than 1. And for R is less than 1, they write it as 1 minus R and 1 minus R. So it's basically the same thing. Just that like it is basically the same thing. If I take negative both of the sides, I'll get this same formula as well. So you guys need not remember both of them, just remember one of them. So I prefer you guys go with this one. So throughout this video, we'll be discussing this formula only. And now see, like, if you guys are wondering what would the sum of this be, 1 2 4 8 infinity, so what would the sum of this be? I think the first answer that clicks your mind is infinity. Yes, you're right. The sum of this would be infinity. Like, because this would be going. Like, if I talk about the 10,000 terms here, so it will be a really big term, and then I add this to all, so it will be infinity. Right. Now, let me just ask you another question. What will be the sum of this? Minus 1, minus 2, minus 4, minus 8. Goes on. It can be infinity or minus infinity, whatever you call it. So like it will be infinity, it's not defined. So what now if I ask you another question, give me a moment. Yeah, so if I ask you another question, 1 plus 1 by 2 plus 1 by 4 plus 1 by 8 plus dash 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 up till infinity, so what will the sum of this be? If your answer is infinity, then you're wrong. So see, now this term is decreasing. It keeps on decreasing. It keeps on decreasing. So like once the term would be 1 by infinity, so it would be 0. So it is possible to calculate the sum of this. So now how do we do that? See, first of all, there's a relation. We can only use this formula. Write the formula first. A divided by 1 minus r. So this is s infinity. Like, if I want to calculate s infinity for this particular example, a would be 1 and r would be 1 by 2, right? So s infinity for this example would be 1 minus 1 by 2. So which is 1, 2 minus 1 by 2. So which is what? 2, right? So s infinity for this is 2. Now there is a limitation for this formula. It's only applicable when mod of r is less than 1. Seems a bit weird, right? Like, what did he write or something? So let me just get to this point. We had talked about an example, right? 1 2 4 8 etc. So in this example, r was greater than 1. Mod of r was greater than 1. So if mod of r is greater than 1, the sum goes on to be infinity, right? So this cannot be applied. Similarly, if mod of r, similarly, if like minus of r is greater than minus of 1, like I'll give an example. So this goes to be 1, then minus 2, 4 minus 8. So common difference is this is minus 2, right? If I ask you guys the sum for this will also be infinity, right? The sum for this term would be infinity, because it keeps on going, so it's going to be infinity. So I guess you guys have understood this point, why mod of r will be less than 1. So I'll just write, let me just clear this real quick. Right. So now we'll just practice one more example based on this. You guys try this by yourself. 1 minus 1 by 3 plus 1 by 9 minus 1 by 27 up till infinity. Calculate s infinity. So I hope you guys have tried this problem by now. So now this will be 1 minus. Now what is the common difference for this? See, in order to calculate common difference, you can take any two consecutive terms and divide them. So this is minus 1 by 3 by 1. So there's a common difference of minus 1 by 3. Suppose you guys took these two terms, 1 by 9 minus 1 by 3. You'll get the same result, minus 1 by 3. So you take any two consecutive terms, you'll get the same result. So what is r for this? Minus 1 by 3. So minus 1 by 3. So which is 1 plus 1 by 3. So I think the answer is going to be 3 by 4. Right. The answer is 3 by 4. So if you got this, congratulations, you have learned the concept for GP. So this is all about GP. Required to solve this problem, like GP is a very big topic. You guys must be studying it in class 11th. So yeah. So we'll just keep a note at the formulas. Let me just erase this. I'll copy this here. So we would not be requiring all these for all this. Yeah, so now we have learned the concept of GP. So let's read about the problem. A system of infinitely many resistors is shown below. Okay, infinite resistors. Each resistor has a resistance of R. Each row has twice as many resistors as the previous one. So twice as many resistors. So if this has 1, this has 2, this has 4. So this is, you guys see, right? What is this becoming? This is becoming a GP, right? An infinite GP. Right. Okay, so how much power, so I'll just read out part A. How much power would be generated by this combination if the kth row had a potential source of V connected across it? How much power would be generated by this combination? If I'm just gonna delete this, just take a look at this. Yeah, okay. So how much power would be generated by this combination if the kth row had a potential of V connected across it? So this problem is fairly simple. So now see, this resistance is R. For the second row, it's R and R. For the third row, it's R, 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 and R. Like there are 4 resistors. R, 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 R. And then this goes on. So now, if I calculate the equivalent resistance, will I get something like this? R, 2R, because the resistors are in series. 4R, 8R. This goes on till infinity. Now you guys are seeing, right? This, wait, sorry for my bad diagram. Now you guys are seeing, right? These resistors are in parallel. In parallel, what remains constant? The voltage between across these points remains constant, because this is at the same potential with all these and this is at the same potential with all these. So the difference between them remains constant. So if the kth row has a potential of V, can I say that the entire resistance combination has a potential of V? So if I reduce this, see, I get this. And if I reduce this, R equivalent, so these 2 points, wait, I'll represent them by red. This one and this 2, these 2 have a potential of V between them. Agreed? So yeah, now our challenge is to, now we know that power will be equal to V square by R equivalent for this combination. So now our task is just to find R equivalent. So how will we find R equivalent? So now look at this figure. Look at this figure. These are all in parallel. So what is the resistance of parallel? 1 by R parallel is equals to 1 by R1 plus 1 by R2 plus 1 by R3 plus dot dot dot. Like for this example, this is R1, this is R2, this is R3, R1, R2, R3, and dot dot dot. So now for this example, one by R parallel will be equal to 1 by R plus 1 by 2R plus 1 by 4R up till infinity, right? So 1 by R parallel is equals to, may I take 1 by R common, so I'll get 1 plus 1 by 2 plus 1 by 4 up till infinity. So if you guys remember solving this came out to be 2. So R parallel would be R by 2. We got this, right? So now just substitute R equivalent or R parallel, whatever, R parallel in this. So what do we get? P is equals to V square divided by R by 2. So P is equals to 2V square by R. This will be the power generated by this combination. This is what was asked in the question. This will be the power generated by the combination, right? So this is the first part. This is the A part of the problem. Now let's talk about the B part. This one does not even require GP. This only requires Ohm's law. what is the potential? There's a current I flowing through the kth row. There's a current I flowing through the kth row. Okay. So what will be the potential difference across a single resistor in the lth row? Okay, wait. Just take a look at the solution once. Yeah, I'm going to erase it. Delete. Yeah. So now, see. Now, I hope everyone knows what Ohm's law is. Ohm's law states that V is equals to IR. I'm not going to the intricates, like just a thing. V is voltage, I is current, and R is resistance. Everyone must be knowing this. So yeah, let's begin now. A current I is flowing to the kth row. So like if I can write, see, V is equals to IR, and in this parallel combination, V remains constant. V is constant. Let me say the current to the first one is I1, I2, to the third one it's I3, to the kth row it's IK. So can I write I1, and this is R1, like for this row, this one's R2, this one's R3, till Rn. So can I write I1 R1 is equals to V? I can also write V is equals to I2 R2, and also write V is equals to I3 R3. I can continue writing this like V is equals to In Rn, right? So now can I write, see, for the kth row, so V is equals to I K R K, and V is also equals to, for the lth row, I want to find the potential difference across a single resistor. So I need to basically find the current in the lth row, IL RL. So I can write IK RK is equals to IL RL. I hope this point is clear to everyone. Now most of the problems completed. So see, the kth row has how many resistors? 2 to the power k minus 1 resistors. So the lth row will have 2 to the power L minus 1 resistors. See, the first row has 1 resistor, the second row has 2 resistors, third row has 4 resistors. So this will be 2 to the power 1 minus 0, 2 to the power 2 minus 1. See, and now if I see, for this k is equals to 2, for this third row there are 4 resistors, so this is 2 square. So can I write, for the kth row it will be 2 to the power k minus 1 resistors, and for the lth row it will be 2 to the power L minus 1 resistors. So IK into, now they are all in series, so they'll become 2 to the power k minus 1 R is equals to IL into 2 to the power L minus 1 R. R and R get cancelled. IK is given to be I, right? The current in the kth row is given to be I. Okay. So this into 2 to the power k minus 1, 2 to the power L minus 1 is IL. Now if I can write this, 2 to the power k minus 1 plus 1 minus L, like I just took it upwards, is equals to IL. So this plus 1 and minus 1 get cancelled. So I into 2 to the power k minus L is IL. See, this is IL. Now I have to find out potential difference across a single resistor. So see, there's a single resistor. I have to find out the potential difference between this in the lth row. So what will it be? Delta V across a resistor is equals to IR. So delta V is equals to 2 to the power k minus L into IR. Right, I just took this IL and substituted it here. So we get this answer. So the potential difference across a single resistor is 2 to the power k minus L into IR. So I hope you guys enjoyed this problem, and stay tuned for the next video. And of course, do let me know in the comments if you want a video regarding a particular concept or topic. I'd be happy to make one about it. Thank you guys.